So we just add them all up. Okay.
Use your process to estimate the mean number of minutes per day. Yeah.
33 plus 40 plus 45 plus 49. Okay, I'm not writing all of these.
Just add it and write.
Say number of minutes by number of students. So that's going to be 8 plus 24 plus 33 plus 40 plus 45 plus 49 plus 53 plus 56 plus 50 plus 61 63 plus 65 so 67 plus 69 plus 71 plus 72 73 75
76.
76. That's it. Pray that we got all those numbers right, and we get divided by 19 is 55.684. Minutes per day. Using the table of data, calculate the mean number of minutes spent per call. Was your estimate close? Mean number of minutes per call. What is your estimate close? What does it mean by using the table?
What is asking in the question? Using the both table of the data, calculate the mean number of minutes spent per call. So that is only what we have found out this the mean.
That's what I'm wondering.
Calculate the mean number of minutes spent per call. That is around 55.6.
We are supposed to do 115, right? Yeah, we are. So for A, is it asking for the mean value theorem? What was the mean value theorem again? So for mean value theorem,
So it is the same question, right?
no. I think what they're asking us is to use a different method.
Calculate the mean number of minutes spent per call.
That's B, then this is A.
Yeah. And for the first one?
For A, we can say, so what was the mean value theorem again? It just says that there is always like a tangent line, right?
Use the table of the data, calculate the mean number of minutes spent per call. Was your estimate close? And then the first question is, estimate the mean number of minutes per day spent per call. Mean number of minutes per day spent per call, and this one is mean number of minutes spent per call.
13, blah, blah, blah. In problem 13, you determine the members of the class, summarize how you calculated the average, blah, blah, blah. use your process from 6113. What's the process? With blocks, build a tower to represent the size of your immediate family. As a class, stand in line by family size. By looking at the classes, while you estimate the average number of tickets each person should receive. If you graph this data, what will the bar graph look like? Decide how to redistribute the cubes so that each person has the average number of cubes. How many tickets should each senior receive?
So the bar graph and which the data is given in tabular form, both are same, right? Eight, then 24, then 33. Are they saying that the bar graph data we have to write and then the tabular one we have to write and then we have to check the mean? The mean number of minutes per day spent per call by these 19 students. 8, 24, that is something 34, 35, 40, 26.
I don't know what it's asking. What process are they asking for? Okay, in the process of above, they say with blocks, build the tower. What's your class and by size? If you look at the graph,
In the first question, use
you determine the mean number of tickets of your class. If you graph this, decide how to redistribute each graph. How many tickets should each senior receive? Each student receive, essentially. Okay. So if each student should receive that many tickets, so I think they're just telling us to estimate just by looking at it. Looking at the graph, maybe. Because that's the quote unquote process that they used before, no.
By looking only in the graph, how we will find it. And
when
I see the graph and the tabular form, the first one is given 8, so that is almost close, that is right. Then 24 is also that. Then the third student is 33. Then the fourth student is 40. Fifth student is 45. So graph is also showing that is the thing. Same thing.
Yeah, most of the numbers.
Estimate the mean number of minutes per minute per spent per call. And this is calculate. Okay, estimation means we have to just see and means assume, right? Something like that.
Yeah, so we can assume that it's somewhere around like 55 or around 60-ish. Because like if I'm just using my eyes, I'm assuming that the center is somewhere around the mean. Okay, most of the values are I don't know. I think I'd place it around 50-ish. I don't know how to answer this, so I'm just gonna put down something.
No. If you see, the highest one is nearby 80 and the smallest one is nearby 10.
Right,
so we can, but see the graph is
so
increasing.
75, so 76 plus 8, 84. 84 divided by 2 is just 42, which is nowhere close. So,
and if you take 10 plus 80, that is 45.
It's
Only the
fine.
first and the last one.
It's an estimate. It doesn't need to be that close.
Oh,
It's better
okay.
to just move on.
Okay.
What is
Actually,
the
the graph
total?
is sitting to the right.
Mm.